The Wheatstone Bridge. When the reading on the meter is 0, the circuit is called a balanced Wheatstone Bridge. When the bridge is balanced, there is a mathematical link between the values of R1 and R2 and the values of R3 and R4. The link can be written as an equation as such. So our Wheatstone Bridge formula is R1 over R2 equals R3 over R4 when the connecting meter reads 0 volts. When the reading on a meter connected across the bridge is 0, the circuit is called a balanced Wheatstone Bridge. When the reading on the meter is non-zero, the circuit is called an out-of-balance Wheatstone Bridge. So in our circuit, we've got two potential dividers, one with a 100 ohm resistor as R1 and R2 as our 220 ohm resistor. Then we have a 470 ohm resistor as R3 and a variable resistor as R4. We have a multimeter connecting the two potential dividers, which we will use to take voltage readings. First, we are going to calculate a value for the variable resistor R4 in order for it to be a balanced Wheatstone Bridge. So, if R1 equals 100 ohms, R2 equals 220 ohms, and R3 equals 470 ohms, then using our Wheatstone Bridge equation, we can say that 100 ohms over 220 ohms equals 470 ohms over R4, and expanding that, our value for R4 is 1034 ohms. So we're now going to set R4 to the value of 1034 ohms, which we've just calculated. And then we're going to switch on the multimeter to see whether it's balanced. As it's not completely balanced, we'll play about with it until it is. So we have a balanced Wheatstone Bridge at 1043 ohms. So it's 1043 ohms. So we're now going to increase R4 in 1 ohm increments and record the voltage each time. So at 1043, it is 0 volts. 1044 is 1 millivolt. 1045 ohms is 2 millivolts. 1046 ohms is 3 millivolts. 1047 is 5 millivolts. And 1048 ohms is 6 millivolts. So we're now going to return to 1043 ohms and do the same except decreasing in 1 ohm increments. So for 1042 ohms, it's minus 1 millivolt. 1041, it's minus 3 millivolts. 1040, minus 4 millivolts. 1039 is minus 5 millivolts. And finally, at 1038 ohms, it's minus 6 millivolts.